Okay, we are going to do more radicals, but we're going to do some operations this time. So we're going to start with adding and subtracting, and then we're going to do multiplying and dividing. So even though these look scary, it's not that bad. So you can only add and subtract like radicals. In other words, they must be exactly the same underneath the radical. Then just combine like terms. Okay, so what does that mean? So do you remember when we were trying to combine like terms, right? 2x plus, let's do it over here, right? 2x plus 3x equals 5x. But if you have 2x plus 3y, you can't simplify it, right? Because you need the same variables to combine like terms, right? So it's the same with radicals, it just looks ickier, right? So we see here have a root 7 and a root 7. So since those are the same, we can just add it. So we have the outside, we add it, 3 plus 2 is 5, and then we just keep the rest, right? If you wanted to replace it, like let's say this, let's use a dummy variable, which is a vocab term that we haven't gone through, but we might. So let's say x equals root 7. So we have that, we get 5x, but then we have to go back and we do 5 root 7, right? So it's the same idea, it's just radicals. And sometimes these things we have to, that's a good example of that, number 2. So we have root 3 minus root 48, so we need to simplify this. So we have root 3 minus, okay, so if we're doing 48, right, and we can write the perfect squares here, right? 1, 2, 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 36, 4, 81, 100, right? So we can see this 48 is going to be divisible by 16, so we do root 16 times root 3. We get 224, 212, 26, 23. We get to pull out a 2 there and a 2 there, so that's 4, and then we're left with a 3, right? 2 times root 3. So we have root 3 minus 4 root 3. And this, remember, there's like a 1 in front of it. So we could write that as 1 root 3 minus 4 root 3, and then we just do 1 minus 4. Okay. So here's another one. We have 4 root 2 plus root 3 minus root 2. So if we look here, right, we're trying to combine like terms. The root 3. So we're only allowed to combine the ones that are the same color. So we're going to do 4 minus 1. So we have 3 root 2 plus root 3. We're just highlight it so that you can see. But I'll also just write it to the side without the highlighter so it looks a little cleaner. Okay, here's another one. So we're going to see, right, we could pull out the 9. So we get root 9 times root 10 minus root 4. We're getting, right, even though we're not fully done with the problem, we can see where we're headed, right? We can look to the future. We see that we have a similar radical, same term, so eventually we can add and subtract it. Right, so this turns into 3 root 10 minus 2 root 10. 3 minus 2 is 1. So we get 1 root 10. But we don't want to write it like that. We just want to write it like root 10. Right, we always want to simplify. Okay, adding and subtracting is just like adding and subtracting like terms. I'm going to highlight here, right, like terms. Okay, multiplying and dividing. We have the product property of radicals. This is a really important one. Property of radicals. Okay, so we've been doing this, right? Like we have been breaking down 10. So the trick with this is now taking into account when we have a number outside, right? So remember, we multiply radical, multiply numbers outside radical, and then multiply, let's do like a comma, multiply numbers inside radical, right? Let me simplify. So let's do an example. So this is written really weird. You have to be careful. 2 root 2 times negative 4 root 6. So this isn't a minus sign. This is to multiply the outsides, right? So I'm going to do outside and then inside. So we have 2 times negative 4 is negative 8, and then 2 times 6 is 12. And we're not done yet because we need to simplify. So step 1 was multiply. Step 2 is simplify. So we have negative 8 times root 4 times root 3, negative 8 times 2 times. So we multiplied our radicals and then we simplified. Okay, this one is, we're going to use the distributive property. So we're going to distribute. So we have 4 root 7 times 3 root 2 minus so, right, we did this guy times this guy, so we distribute. And we multiply. 14 minus 4 times root 7 times 2. We could move the 2 in front and we get 8 root 7. And that's it. We don't simplify any further. All right. Quotient property of radicals. So if we have something divided by another, we can rewrite it like this. Root 49, and then that's easy to see. This is a perfect square of 4, this is a perfect square of 7, and we're done. We can rewrite this as square root of 121, and this is 5. So that's the quotient rule. These were simple examples because we used perfect squares. Okay. This is really important. Okay, it is not appropriate to leave a radical in the denominator of a fraction. Multiply by a form of 1 to get it out, right? So this is the identity property of 1. Another vocab turn. Okay, so rationalize the denominator. This is a little multiply by 1, and we're going to choose whatever is in the bottom in the radical because we want to get rid of it. So we're going to do root 11 over root 11, and now we just multiply across. We get 3 root 11 times 11, right? Because a root 11 times a root 11, you just get to take out the radical, right? And this is already all simplified, so we are done. We can multiply by root 4 over root 4. We get 1 times root 4 is just root 4. Root 4 times root 4 is 4. We can simplify this to 2 over 4. But there was actually something we could have done to make this easier. We could have simplified this from the get-go. So we could have written this as 1 over 2 because we know that root 4 is the same as 2. So it's the same answer. We just denominator, and you should get the same answer, right? In math, there's lots of ways to do the same problem. So it's always about finding the most efficient way, the way that you most feel comfortable with. And here's a hint. You usually feel comfortable with practicing it, and it'll get quicker. So both of these ways, right, rationalizing the denominator or just simplifying right off the bat, you both get 1/2. All right, let's take this guy. Then we're going to try and rationalize the denominator. So we're going to multiply by root 5 over root 5. This, remember, roots inside stay the same, or stay inside the root. So we have root 40 over 5. We're going to perfect square. And then this is 2 root 10 over 5. And then we have, finally, another one, root 12 over root 6 times root 6 over root 6. We get root 72 over 6. This is this is divisible by a perfect square. 36 times root 2 over 6. That equals 6 root 2 over 6. These will cancel out. We're left with just root 2. Here was a trick. You actually could have simplified this right off the bat, right? So 12 divided by 6 is 2. We would have had a root 2, same thing. So this is why we always try from the get-go. We wouldn't have had to go through all of this. All right, a few more examples and then you are on your own. Okay, so you can pause the video, but happy to have you do them along with me. Okay, so we have 3 root 7. Let's simplify these. Minus 2 root 4, perfect square, times root 7, plus root 9 times root 7. So we have 3 root 7 plus 3 times root 7. So 3 root 7 minus 4 root 7, multiplying these two together, plus 3 root 7. Okay, so now the terms. So we have root 7, so we could just add the numbers in front. So 3 minus 4 is negative 1, plus 3 is 2 root 7. This one's tricky, but you just got to make sure you are multiplying correctly. So this is double distribution. Or box method. All of these will work. So we want to make sure that we're not just squaring it, right? We don't distribute the square. That's wrong math. Like a multiplication problem, right? Whenever you see something squared, you're timesing it by itself. So we have 3 root 3 minus 2 root 2 times the entire quantity of 3 root 3 minus 3. Foil box method. I'm going to do just straight up foil. First, outside, inside, last. So we have first 3 root 3 times 3 root 3. Outside, 3 root 3 times negative 2 root 2. Plus inside, negative 2 root 2. Plus last, negative 2 root 2, negative 2 root 2. So you always want to be careful with the signs. You might have noticed that I paused a little bit for some of these. But you want to be careful always. Okay, try and zoom in since I'm writing pretty small. Okay, so we're multiplying our radicals. 9, right? Plus negative 6 times root 6 plus negative 6 times root 6 plus negative 2 times negative 2 becomes positive 4. Root 2 times root 2 is root 4. And then we simplify. So 9 root 3 minus, these are the same. So minus 6 minus 12 root 6 plus, oh wait, no, sorry, this doesn't turn into 9 root 3, it's 9 times 3, because that root 9 turned into 3, plus 2 times 2. All right, so almost done. 9 times 3 is 27, minus 12 root 6, plus, sorry, this is a 4. Ooh, I'm getting, right? These are really easy to mess up, so be careful. 4 times 2 is 8, so we get 35 minus 12 root 6. So you got to be really careful as these, these problems are getting larger and larger and more easy to mess up. Okay. 2 root 5 plus root 12 minus root 27. So we have 2 root 5, that's already simplified, plus root 4 times root 3 minus root 9 times root 3. So we get 2 root 5 plus 2 root 3 minus 3 root 3. We have like terms here. So we have 2 root 5 plus 2 minus 1 is the same as minus 1 root 3. But we don't want to write it like that. We want to write it simplified. 2 root 5 minus root 3. All right, and then finally we have another double distribution. So I'm going to do box method this time. So we have 4 root 5 minus 3 root 2. 4 root 5 minus 3 root 2. So this is 16 root. So I'm going to start taking a shortcut. I know that root 5 times root 5 is 5, so I'm just going to do 16 times 5. And then I'm going to do negative 12 times root 10, negative 12 times root 10, 9 times 2. So I get 16 times 5 is 80. We get to combine the, I'm just going to write it all out. Minus 12 root 10 minus 12 root 10 plus 18. We get 80 plus 18, right? We're combining like terms now. We can combine these two and those two. 98 minus 24 root 10. So lots of algebra, lots of simplifying, combining like terms, having to double distribute, and all with radicals. But I believe in you. You got this. So try those practice problems.